Hello and good morning. And I think that there are people from Dallas, so probably it's good morning, good afternoon. But also I've seen some people from India, so probably for you it's more like good evening or good night, right? So thank you very much for joining to this master course about Istio. We're going to learn what is a service mesh, what is Istio, how you can use it in your Kubernetes, and so on. As usually in this master course, we're going to see some slides and also some demos, some interactive demos, and so on. So let's start. Let me share with you some links. The first link is the homework. Basically, all our stuff it's done following this tutorial that we have developed. So you can follow after the session. This is some homework, so you can reproduce everything that what I'm going to show you at home. Oh, I see that you are from Cape Town, so you're in the same time zone. Probably there it's 6 p.m. So in your case, it's like me. Good evening. And then let me share you another link, which is this is the slides. Okay, so if you want to follow the slides on your own or later, you can just download them and use it. And I think that now we can start. Let's start. Just remember that today it's August 17 and we are doing an Istio course, but next Wednesday, August 19, we've got the canary. Okay, so pretty cool. If you want to start using Kubernetes and serverless, then canary master course is for you. Then my name is Alex Soto. I work in Red Hat. I'm the co-author of several books. And let's start. As usually, we've got a survey link. If you got any comment, then here it is. Yeah, okay. You said that in Tecton is 29. Yeah, probably it's on 29, but it has not been. It's a matter of a space. Yeah, I think that you are right. That 29 of 7 Tecton. Yes, but this is for July, so it's past. So yeah, we've got Tecton in the last thing. So sorry, I got the chat. So if you have any questions, any point that you want to do, just use the chat. I'm just reading and trying to answer as soon as possible. So let's continue. And the survey link, it's here. If you have any comment, anything that you think that it would be great to have an improvement, or you like it, or you don't like it something, then just use this link. Then also you can download some books. This book is introducing Istio service mesh for microservices for both Soto and Christian Posta. You can download it for free. Just go to developers.redhat.com and register, and you can just download the book. You can also download the migrating to microservices database. And let's start with the tutorial where we're going to see some kind of setup, deploying microservices, observability, traffic control, chaos, resiliency, security, all this kind of stuff. We're going to see it, how to use it with Istio. But first, let me show you one thing, which is here. And first of all, let me share with you the link so you can also interact with me. Let me get, first of all the roots. All the URLs, because I don't remember exactly the URL. Is this one? Okay. And I'm going to share with you in a few moments. Is this one? Okay. Now, basically, here is the link. I know that there is some kind of delay. Okay, so probably when you see what I explain and what I'm doing, it's a bit of out of sync. But notice that I've got here a web page, which basically is going from green to blue, and then to green again, and then green again, and then blue, and well, you can see that it's iterating, right? Probably if we wait a bit, you'll see also yellow. I don't know. Okay, not yellow. No, it's just totally random. The thing how it works is I've got here my Kubernetes cluster. In fact, is OpenShift. It's an OpenShift cluster, but you know that OpenShift is Kubernetes. So I've got here my Kubernetes cluster. Even if you want, you can do get nodes, and you can see there is all these nodes, worker nodes, master nodes, all of them running. Okay, and notice that I've got 2 pods, which returns a blue color two pods which returns a canary color and two pods which return a green color. Okay, so now every time that I send a request, if the request is sent to the blue pod, then it returns blue. If it goes to the canary, it goes to yellow, and if it's green, it goes to green. So notice that now it's yellow. It means that the request has been served by the green pod, the yellow pod, or the blue pod. Notice the key. Okay, and it's using a round-robin approach. Then, what's happening if I want to send all my requests to the blue pods? I just need to do one thing. It's just slash 7, 8, I guess. Yeah, 8 and blue. No, it's 7. Sorry, I've got here now 7. Now I'm sending all the requests to blue. Okay, so any request goes to the blue channel. And notice that now I get all the time, over and over and over, all the requests goes to the blue. Now what's happening if I want to send all the requests to the green? I can do it as well. Look, I can do green. And if we wait a few seconds, now it goes to green, and all the time goes to green, right? And notice that I'm not redeploying anything. I'm not changing my code. I'm not changing the pods. Notice that the pods are still the same. No, pods are still the same, which it's 7 hours and a half. Okay, they're running, and I'm changing the traffic, right? I'm changing the how the requests go through my cluster. For example, what else I could do is just do, for example, one interesting thing. How about Firefox? Okay, so what I want to do now is changing the request depending on the browser. So there we go. I've got here the Firefox. Notice that this is a Chrome, and in case of Chrome, it's green. But now I've got here my Firefox. Let me find it. Okay, here is Firefox. And what's happening if I do this? Since I'm in Firefox, now the request goes always to the canary pod, to the yellow pod. Okay, so notice that with a service mesh with Istio, I can manage the traffic not only globally or for percentage, 100% of traffic goes to blue, 100% goes to green, and so on, but also depending on the environment. So if it's Firefox, it goes to the yellow. If it's Chrome, it goes to the green, and so on. And probably most of you are wondering how are you doing this? Because it's quite interesting, but I have no idea how to do that. And this is what we're going to explain today. So let's start with some slides before we get it started again with these examples. Then what's happening in the past? We've got this old school way where we've got our monolith application with one database and everything was inside this, artifact. But now the new school, it's more like a service architectures. It's not just microservices, maybe just a service architecture, but you have got something like this, right? You've got several services, all of them interconnected with their own database, and this produces a mesh of communication, of a network, right? There is a mesh, right? And you need to find ways to deploy these services in an easy way. And this is where Kubernetes and OpenShift give you power to the next level, right? You can deploy services really, really easily with Kubernetes and OpenShift. Because at the very end, if you think about microservices or services architecture, at the end, it's a distributed computing. You've got service A, which runs inside the JVM, which at the same time it runs in the operative system and makes a request to another service, and this service makes a request to another service, and then it returns a response, and so on and so forth, right? So at the end, microservices is nothing more than distributed computing that we saw or we work in the past, like for example, Corba, RMI, or AGBs. But what's happening with this kind of architectures? Well, there is one big problem, and it's like, what's happened if one of the service fails? And this service is in the middle of the mesh, like this one that you're seeing here, that is with this red cross. When this service fails, there is a cascade of failures, right? The service that is failing and all the services that directly or indirectly cause this service are going to start failing as well. So now you've got this kind of scenarios where you need to think about how we could make our application more resilient. So when there is a failure in the middle of the mesh, it's not propagated through all the services. And to avoid these kind of problems, the microservice has one thing that it's called microservicilities, or what I like to call it cross-cutting concerns for microservices. Basically, we've got our service that can be written in Go, in Java, in JavaScript, in Spring Boot, in Vertex, Quarkus, wherever. Okay, this is our service, this is our business service, but then there is around the service some kind of new things, right? We need to define an API to interact with the service. We need a mechanism for discovering services. We need a way to invoke services. We need to make all services elastic so we can scale up, scale down really quickly. We need to make all services resilient, right? We've seen in the previous slides that what's happened when a failure happens in one service. Is this service propagated through all the architecture or not, right? This is why resilience is really important. Pipeline, we need to define a pipeline. We need to find a ways to authenticate between services, logging, monitoring, tracing. All this stuff is required in a microservices architecture. So usually what you end up doing is something like this. We've got our container, because at the end Kubernetes works with containers. We've got the JVM, then we've got our service, and inside our service we start adding all these microservicilities, right? So we are adding all these capabilities embed inside our business logic. For example, discovery, load balancer, resiliency, metrics, tracing. Probably if you are into the Java ecosystem, you are already using, for example, Hystrix, right, for resiliency, or resiliency for J. Maybe you're using Jigger for tracing, right? So nothing new, but you are putting all this stuff inside your service. And this has some advantages because, at the end it's code, but it has a lot of disadvantages. For example, what's happened if my service A is in Java and the service B is in JavaScript? Then I need to learn how to do resiliency in Java, how to do resiliency in JavaScript. If the third one is in Python, then I need to know how to do resiliency in Python, and so on. And also, if you are into the Java world, you know that class path is not isolated, and it means that you can start having some kind of conflicts between libraries. So it's, we've been doing this in this way, and it's okay, but maybe there is a better way to do that. And basically, if you start using Kubernetes and OpenShift, then we are more or less fixing some of these problems. For example, if we are using Kubernetes, the discovery problem is solved by using the Kubernetes service approach, right? That it's like a stable IP and a stable DNS name. Then we've got the invocation. It's really easy to invoke services with Kubernetes, and thanks of the kubectl scale approach, we can scale up and down really easy our services. Of course, if we are using OpenShift, then we are also covering the pipeline approach by using Tekton or using Jenkins, and logging and monitoring is also covered. But we still have some missing pieces out here. And this is exactly what Istio fixes, right? Istio is a service mesh which covers all these pieces that are not covered by Kubernetes or OpenShift, right? There is some overlapping, like for example in monitoring and in discovery, but it's also covering the tracing, the authentication, and the resiliency thing. So before Istio, we've got something like this: service A that calls service B that calls service C, with all these capabilities embedded inside the service. But thanks of Istio and one thing that is called sidecar, and a sidecar is just a container that lives inside the pod. Because remember that a pod can contain more than one container. So what we are going to have now is my service inside a container, and in another container I will have all these capabilities implemented. So when we start using Istio, what we've got is something like this. We've got a pod, with a pod with two containers, one container with my business logic, and another container, which is the sidecar container, which implements all these features. And now, when we start using Istio, service A communicates with the sidecar container. This sidecar container of service A communicates with sidecar container of service B, and the sidecar container of service B communicates with service B, with the real service, right? So you can think like this sidecar container is just an interceptor of traffic. It intercepts the traffic and communicates. So if you want to know what is inside this sidecar container, is an envoy proxy, okay? Then let's start, right? Because this is theory. You can read about theory in a lot of places. So let's start first of all, for example, showing you the observability patterns that you've got with Istio. Istio, when you install Istio, by default it comes with Jigger, okay? So you can just check. I have no traffic yet, I guess. Let me check. No, there is no traffic. Okay, perfect. Then let me generate some traffic. First of all, I'm going to Kubernetes tutorial. Okay, this is the tutorial that I've shared with you the link before. Basically, if I do I get pods, you see that I've got a customer, a preference, a recommendation V1, and a recommendation V2. And notice that each of these pods contains two containers, one with the business code, another one with the envoy proxy. Okay, now what's happening if I do a curl to customer? Okay, export gateway. Now notice I've gone from customer preference recommendation V1, and then if I do curl, I go to customer preference recommendation V2, right? Because remember that by default, if there is nothing, it's using a round robin approach. The same that happened with the blue, green, and canary, right? That it was iterating. The same happens here, right? I can go to V2, then V1, then V2, then V1, and so on. So it's iterating, over all the pods. Now, what's happening if I want to send all my traffic to V1? Okay, I need to do two things. The first one is register. Let's call it in this way. Let's register that there is a recommendation V1 and there is a recommendation V2. Okay, because at the end, Istio needs to know what is V1 and what is V2. So I'm going to do kubectl apply -f. Oops. No, I'm not in the correct directory. Sorry, I need to change to Istio tutorial. And now kubectl apply -f Istio files. Destination rule V1 V2. Okay, so I'm just saying, hey Istio, there is a recommendation V1 and there is a recommendation V2. I can do a cat if you want and see that it's just a kind of destination rule. This is an Istio resource which says that I've got version V1 and I've got version V2 of the host recommendation. We will see later that destination rule is used for more and more things, but for now, for the sake of simplicity, you can think that destination rule is for registering services, right? Hi Pavan, you asked me, what is the difference between Envoy and Istio? Okay, I've gotten a slide. Let me share with you. I think it's here. Okay. Let me see if it... Okay. Envoy proxy, it's what it's inside each of the pod. This is the envoy. And Istio is this part, this control plane, which basically is in charge of configuring all these envoy proxies, right? So basically Istio is like a control, or it's a way to manage all the envoy proxies in a single way, right? So instead of having to go to envoy proxy of service A and configure it, go to envoy of service B and configure it, go to service C and configure it, just use Istio interface or Istio frontend, and then Istio is in charge of, as you can see with all these arrows, configuring envoy at once, right? This is the difference. One thing is a proxy, envoy is a proxy, and Istio is just a piece of software that manages all the envoy proxies of your mesh. So, okay, now I've registered recommendation V1 and recommendation V2. Now I want to notice that I can still do curl and I go to V1 and V2 because now I've just registered the service. I say there is V1, there is V2. Okay, now what I want to do is send all the traffic to V2, for example. So then I can do kubectl apply -f is, oops, sorry, Istio files, virtual service, recommendation recommendation v2. Okay, and now what's happening if I start doing curl? Okay, I go v2 all the time. Probably some of you are saying, okay, and how this file looks like, and I can show you. Notice that I'm just saying there is a service which is called recommendation, and I want to send all the traffic, right, 100% of the traffic to recommendation v2. What's happening if I want to send all the traffic to v1? Okay, that's pretty easy. I just need to have my virtual service pointing to v1, which is somewhere over here. And now I can do a curl, and I get it v1 all the time. So notice that I can change the traffic from v1 to v2 really easy. Now, what's happening if I want to do, for example, a canary release? A canary release is not sending all the traffic to one version or all traffic to another version, but splitting the traffic between two versions. So for example, I can say I want to send the 75% of the traffic to v1 and 25% of the traffic to v2. What I can do is just do a kubectl apply -f Istio files virtual service, boom, 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 boom. Here I got the file. Now I'm sending the 75% of the traffic to v1, 25 to v2. So you can start doing curls. You see that there is some v1s, but someday you notice that now it comes some v2s, v1s, v2s, v2, v1, v1, v2, v1, 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 right? So it works pretty well, right? And I can start doing a canary release with Istio really easily. Notice, and that what I want you to notice is that I am not redeploying anything. My pods are always the same. Notice that I can do kubectl get pods, and notice that they were started 7 hours ago. So I'm not redeploying anything. I'm just changing or managing the traffic between services. And that's the key point of Istio. Now, if you want to see how this canary release works, you can expect probably most of you were expecting something like this. It's just a virtual service with recommendation, and I'm sending the 75% of traffic to v1 and 25% of the traffic to v2. And of course I can do kubectl apply -f, Istio files, virtual service, 50-50. Now I'm sending 50% of the traffic to v1, 50% of traffic to v2. Let me do this curl. Notice this v2, 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 v1, 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 v2, v2, v1. Okay, so pretty cool. Nothing really complex, right? I just install Istio and start applying some resources. In this case, as you might expect, that there is a weight 50% to v1, weight 50% to v2. Pretty cool. Hi, Pavan, you are asking me dynamic canary releases. Not directly with Istio, but there are some tools out there that are mounted atop of Istio that allows you to do that. Yeah, it's possible, but not by default. You need to install another thing. Okay, I think that I don't remember. One is from Netflix, but I cannot remember the name. And another one, I think that it's Glue Shot. No, but it's not. But it's from Solo. I don't remember exactly. But if you check solo.io, I know that they have something. Okay, you here that they have something to do that. This thing that you are mentioning now, and also there is a Weaver Kubernetes. This Weave works. Okay, that if I remember correctly, yeah, they also have a solution for doing this dynamic canary. Okay, so not by default, but something that you can either mount by yourself by inspecting the error codes, or either using any of these tools. Notice that now that you mentioned this HTTP status code, notice that by default, Flaker, yeah, one is Flaker, yeah, it's from Weaveworks, yeah. Flaker is one, another one is for Solo, yeah. Hola Pablo, you said, can I have traffic route based on cookie headers? Yeah, wait a second, because this is the next demo that I wanted to show you right now. Yeah, now, we've got this 50-50, and you probably will say, okay, that's pretty cool, but how have you done depending on the browser, right? So let's do kubectl, apply, -f, Istio files. And for example, let's go to Safari. Okay, I've got here, and I want to do, or I want to send the traffic if it comes from a Safari browser to recommendation v2, and if not, to v1. Okay, so now I can do a crawl, and I'm going to v1 all the time because, of course, this is v1. This is not a Safari. But let me open a Safari that I always skip to open it. So now here it is. Okay. Let me do an echo of gateway. I'm going to copy it. I'm going here. I do customer, and I go to v2. So if I do a curl, I go to v1. If I go to Safari, I'm going to v2, right? So how this works? Well, it's really easy. It's just this file. And notice that I'm saying I want, or I have a recommendation service, okay, and I know that there is a header which is called user agent, and if the user agent is Safari, or it contains Safari, right, because this is a regular expression, then move to recommendation v2, else go to recommendation v1, okay? With just this thing, you can start doing all this stuff. So this is the user agent header, but you could use a cookie, or you could use another header, your own custom header. There will be no problem, okay? In this case, I'm just using the user agent. Then, now that you've seen how we can manage all the traffic, let me show you another great feature, which is called shadowing traffic or mirroring. Some of you maybe are asking, what is mirroring exactly about? Mirroring is about taking a request and send the same request to service v1 and service v2, okay? But the important thing here is that the response will always be from service v1, and the service v2 will never send the response. So the response is just ignored, okay? So you can think like when you go to v2, v1 is normal, and when you go to v2, it's a fire and forget request, right? Because you send a request, but you do not care about the response. So let me show you this, how it works, and then I will explain you why it's useful. So I've got here, kubectl get pods, I've got recommendation v1, recommendation v2, okay? Let me, for example, start sending all the traffic again to, for example, v1 and v2, okay? So now I've got again this 50-50, and notice that what I want you to see is this number, okay? Notice that in this case it's 31 and this is 30. Basically, this is a counter. Every time that this pod or this pod serves a request, it's incremented. Notice that v1 has served more requests than v2, okay? Even I could do, for example, this. I could copy this and could do kubectl logs -c recommendation, and notice that here I can see in the logs that it is 31 responses. Okay, I can do a curl again. Now it's v2, notice that it's a 32, and I can do kubectl logs, and here is a 32. Then let's add a mirroring approach. Let me do kubectl apply -f Istio files virtual service mirroring. So basically I'm saying I want to send the request to v1 and to v2. The response I want to come from v1, but I'm also sending the request to v2. Notice that here is the number is 32. Now I can start doing curls. I do one and it comes from v1, 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 and v1. So I've done 4. And what's happened now if I do kubectl logs? Oops. This, notice that I mean 36. Why? Because remember that the request is sent to both services. Now, how this resource file looks like? It's like this. I can go here, cat, oops, cat. Now, Notice that I'm saying that there is a host, there is recommendation again. Notice that there is a virtual service, and I'm saying that the root is the destination recommendation v1, but I want to mirror to recommendation v2. Okay, now why this is useful? This is really useful because now you can start testing the new version, the recommendation v2, without the end user noticing it. So from the point of view of the end user, they will always receive something from the v1, from the old service, okay? But you, as a developer or as a tester, you want to check for any regression. And what it's better than just using the request that you're sending to v1 to validate that the v2 is still valid. Now, how you can detect these regressions using a monitoring tool, right? For example, Prometheus and Grafana. And the good news for you is that Istio by default, it comes with Prometheus and Grafana and Jigger and Kiali installed. So without doing anything, you've got all this monitoring stuff here. Notice that this is a Grafana that comes, all the data comes from Prometheus, and I can change this to tutorial, and there we go. Notice that I've got the customer service with incoming success rate 100%. Now there is nothing, request duration, inbounds, incoming, outbound services, everything is here, okay? And I've not configured anything. Seriously, it's automatically done for me when I've installed Istio. And of course, I've got also Kiali. Kiali allows me to see my graph. Notice that I here with Kiali can see, notice there is customer v1 that communicates with preference v1, and then there is recommendation, and then there is recommendation v1, recommendation v2, right? And everything is working. I could even, for example, go here and say, let me traffic animation, and let me animations of the last 5 minutes. And notice how I can see that all the traffic, it's going from v1 to preference v1 to recommendation and to recommendation v1 and recommendation v2. Okay. Now, if I change this to only going to v1, you will see that all the traffic only goes to v1. So it's, you know, you've got all this stuff done, implemented for you by default. You can disable, you could enable individually, but you know, by default, it comes with everything. So, okay, we've seen all the traffic management stuff, which hope that you found it useful, but let's move a bit. Let me now do a kubectl delete -f Istio files virtual services mirror. Oops, kubectl. And now if I do curl again, I'm getting from v1, v2, v1, v2 because I delete the mirroring resource, right? Or the virtual service resource. Now, let me show you one thing, okay? Kubectl get pods. I've got here v1 and I've got v2. Then let me go inside, okay? Let me go inside this container. So I'm going to do kubectl exec -ti -c recommendation /bin/bash, okay? Okay, now I'm inside the container. Notice that I'm not in my machine. Notice that this recommendation, I do a PS, and there is no PS. But notice that I'm not in my computer, I'm in inside the pod, and if I do curl localhost 8080, I'm getting recommendation v2 from recommendation because it's, you know, the current. But what's happening if I do this? Misbehave. Basically, notice that now I'm saying any request that I'm going to receive, I'm going to return back a 503. Okay, notice that if I do now a call here, notice that it's returning a 503. Okay. Now, what's happening if I do here and I do a call? What do you expect? You expect that it's going to work? You expect that it's not going to work? Let's do a curl. It goes to v1, right? And you'll say, oh, that's pretty cool. Go to v1. But maybe it's because there is a round robin approach, right? Send another one. Oh, it goes to v1 as well. And now it sends a v1 as well. What's happening here? What is happening is that Istio by default implements an automatic retry. So when I send a request, if the request goes to v1, since v1 is not failing, it returns a valid response. But what's happened when it goes to v2? When it goes to v2, the v2 it's failing, it's returning a 503. And then with this 503, Istio says, okay, recommendation v2 it's failing. By default, I've got a retry. So it does a retry, and the retry goes to v1, and then it returns a valid response. Notice that if you've got several pods of v1, if one of these pods is failing, with an automatic retry, probably it's going to go to another pod, which maybe it's not failing, right? And then it will return back a valid response. So what you can see here is that you are applying by default a resiliency pattern, right? Doing an automatic retry makes your architecture more resilient. Of course, you can configure the number of retries, the jitter time, the sleep time, and so on. I mean, there is a bunch of parameters to configure, right? That by default, there is one retry. Now, so you see that I'm not lying you. I'm going again inside this recommendation. I do a curl localhost 8080 behave. Now it says that all the following requests is going to return a 200. And now I can do a curl again. And now notice it comes from v2, v1, v2, v1. Okay, that's pretty cool because, okay, you've got these automatic retries by default. Let me check if there is any question. Oh yeah, I see there is a question. See, does it add much latency to services with all this filtering in between? Not much. I mean, that I don't have the numbers, okay, but with all the, I mean, that some posts that I've seen, there is not a lot of delay. I remember one guy saying that they were running several, I think that it was like thousands of requests per second without any problem. I don't have the number, right? But if you search in Google, you will find them. But there's not a lot of latency. Also notice that probably you're into a microservices architecture, you're already using Jigger or Prometheus or Grafana, right? So you already have this latency. Of course, it's a bit of latency, that's true, but it's really well performing. Was performing really well, Envoy. Yeah. And then there is another that says, do monitoring components Prometheus and Grafana get installed and configured by default with OpenShift cluster installed? No, they are installed because I've installed Istio. In case of OpenShift, there is this Red Hat OpenShift service mesh, which is Istio. Okay, this is an operator. Then when I install the operator and I start the installation of everything, then by default, it installs all the Jigger, Prometheus, Grafana, and so on, Kiali, and all this stuff. It's installed by default. Of course, you can disable if you want, but they are installed by default. This is not a part of OpenShift. It's a part of Istio. But even if you are using Istio in any other Kubernetes platform, you already have by default all these Prometheus, Grafana, Istio, and so on, because this is a part of the Istio core. It's not about OpenShift. Hey Patrick says if there are replay. Yeah, it's exactly the same link. So after the session, you can take the same link, paste it on the browser, and you will be able to replay as many times as you want. It's exactly the same link. Now let's continue a bit. So notice that now what you are seeing is that I'm just sending remember where we are, because we've been doing some questions, sorry for that. But remember that we've got v1 and v2. v2 was failing, and since there are automatic retries, then the response was always returned valid because it went to v1, right? This is automatic retries. But let me now do another thing, which is deploying another service. I've got here the link, okay? So, wait, no. Now I'm deploying a new v2 service, okay? So I'm going to apply it. Let me check the pods. Notice that there is a new v2. let's see if it works. Notice that it's 0.2. It means that there is no containers yet running. 1.2. Let's wait a bit. Notice that by default, it's doing this. Meanwhile, let me show you one thing. If you're wondering how I can deploy, how can I deploy this? It's really easy. Notice the YAML file. The YAML file is just a Kubernetes deployment, but the only important thing is that I've got this annotation. I'm saying that I want to use Istio inject equal true. Okay, now just setting this sidecar Istio.io inject true, just setting this to true, it makes that this pod will not only contain this container, but also the Istio container. Okay, but notice that the rest is just as any other deployment. Let's see if this is finished. Yes. Now, what's happening with this recommendation v2? What's happening now is that v2 has a sleep of 3 seconds. So now when I'm going to v1, it's pretty fast. When I go to v2, as you can see now, it takes like 3 seconds. Notice that now the request is 1. Now if I go to v1, it's pretty fast, but when I go to v2, it's really slow, right? Goes to v2 because there isn't a sleep. Okay, now can we make this better? And the answer is yes. We could create a timeout at network level. Okay, so you can add timeouts at your code, or you can add timeouts at Istio level. For example, let me show you one thing. Let's apply kubectl apply -f Istio files burial service timeout. So basically, what I'm saying, what I'm configuring here, and probably when you see the file, you will understand, is that I'm saying if the communication to recommendation takes more than 1 second, then send the timeout. So instead of waiting these 3 seconds, what I'm is protecting my colors, right? To have to wait more time that one thing that might think it's reasonable, right? So in this case, my recommendation v2 has a sleep of 3 seconds, but I want to stop the communication after 1 second. So now I've applied it, and what's happening when I do a call? Notice that now it's v1, and now it just takes 1 second. Sorry, now notice that all the time it goes to v1 and it takes a bit of time, right? Why? Because what's happening here is that the resiliency approach and the timeout approach, it's working together. So now what's happening is that I go to v1 and I get back the response correctly, okay? Now I go to v2. The v2 has a 3 seconds sleep, but since I've configured here a timeout of 1 second, after 1 second, it returns back an error code. This error code, it's taken by the resiliency part of Istio. It does an automatic retry, which goes to v1 and it returns the v1. So this is really important thing to take always into consideration. When you are communicating through several services, you need to be able to define some reasonable timeouts. So all your colors do not spend more time than expected. This is a great example of how, without redeploying the services, you can change how the traffic is managed, right? In this case, with a timeout of 1 second. So we are done with this part. Let me delete this. Notice that the timeout service is still there. I'm not going to undeploy it. Burial service timeout. So, oops. So now again I can do curls, and you will notice that v1 is pretty fast, and v2 it takes these 3 seconds. Now let me show you another thing. What else? For example, kubectl. I'm going to check now if there is any question, but let me check. Let me take this exec. Let me go inside the pod again. Foundation /bin/bash. Oops, I've done no. Okay, and now I'm going to do localhost again. 8080 means behave. Okay, now what's happening when I do curl? Again, I'm going to well, it's failing. I don't know, yeah, and it goes to v1. Then I'm thinking, wait. Sorry for that, but let me change, because if not, we're going to spend a lot of time here. Let me deploy again, not here. Let me deploy again the version v2 without this sleep time recommendation deployment v2. Okay, now I'm just changing the time, the one that with the sleep with one without the sleep, right? So we can see the example. Meanwhile, I'm going to check if there is any question here. Yeah, okay, yeah. Okay, so there is no question. So what you've seen so far is that we can manage traffic, and by default, Istio can do automatic retries in case of errors, and we also can define timeouts, right, at infrastructure layer. Okay, now it's running again, and now I get v1, v2, v1, v2 without the timeout. Okay, now let me do kubectl exec -ti. Let me go here again. Remember that in the tutorial, the link that I've sent you, you can also run all these examples. Okay, now I'm going to do curl localhost 8080 misbehave. Okay, and now when I do a curl, again, I'm getting v1, 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 v1 all the time. Okay, remember that I can do kubectl logs, this is important, of this pod, and now notice that the number is number 4. Okay, now let me do the next thing. Now it's failing, it goes all the time to v1. Okay, now let me use siege. Okay, siege, basically in this case I'm going to send with 4 concurrent users 10 requests. Okay, so I'm going to send 40 requests. I run it. Notice that everything works as expected, right? Because there is this automatic retry, right? So when it goes to v1, it returns v1. When it goes to v2, it does an automatic retry, and it goes to v1 again. So everything works, and it's a 200. But let me show you something. Let's check the logs. Notice. Remember that we were in the number 4? Remember here, I can just show you here. It was the number 4. And now we are in number 42. Why? Because the request reaches v2. Since we are reaching v2 over and over again, the request is reach the v2, it returns an error, and it does a retry. And of course, as you can see, this is we are using some resources, in this case pods, machines, for something that is going to fail, right? Because it failed the last time, and it's going to fail. So could we make it better? How about using circuit breaker pattern? I don't know if you know what is circuit breaker pattern, but basically circuit breaker pattern just intercepts the traffic, and when there is an amount of consecutive errors through this service, then the circuit is open and no further requests are sent again to that service until an amount of time. So now Istio by default just does automatic retries, and it means that we are also consuming resources that we already know that it's failing. So let's apply circuit breakers. So when there is some kind of consecutive errors in a concrete service, then let's not send more requests to this failing service. Okay, so let's do here kubectl apply -f istio files destination rule, this one. Okay, so notice that now destination rule it's not only used for registering the services, but also for implementing the circuit breaker pattern. So let me apply it. Okay, now let me show you this file. And what I'm doing here, notice is saying that I want a traffic policy, a new traffic policy. Okay, so I'm registering the services as before, but a new traffic policy where I say that I only want to have one consecutive or one parallel request every time. So at least can only have one request. Max connections is one request per service. And there is this outlier detection, which is saying, it's saying that if in 1 second there is one consecutive error, then eject all the requests. Of course, this is a percentage, so you could put eject the 80% of the requests and so on, but for the sake of simplicity, for the sake of showing you how circuit breaker works, I put it these numbers. 1 consecutive errors in 1 second interval, okay? And ejecting all the requests. Now, remember, kubectl logs. It says that the number is 42. I applied the circuit breaker pattern. Now, let's use ch again. 200 all the time. But, remember, this was 42, and now it's only 43, right? Why 1? Because there is a circuit breaker pattern, which I said, if in 1 second, in the window of 1 second, there is 1 consecutive error, then open the circuit and do not send more requests to this service. And if you check here, notice that the service now is red. You see that it's red? It means that it's failing. Okay, notice that it's here. This means that you've got the circuit breaker pattern and it's red because this is failing. And if you notice, I don't know if I can do a zoom. Okay, notice that all the traffic all the time goes to V1 and not to V2 because the circuit breaker pattern are here to avoid that sending requests to a service that we already know that it's failing. Okay. Hypawan says, does it require all these pods to be in the same namespace in Kubernetes? I think that you can use different namespaces as well. But I think that you should configure the gateway correctly, okay? But yeah, it should be possible, yeah. What you cannot do is because even you can communicate with using with different clusters. What you cannot do, and we're going to see now, is communicate between services that inside the mesh and services that are outside the mesh. Then you need to configure something, okay? But yeah, you can do it between namespaces and even between clusters as well. Now, you've seen Kiali, that is really useful. You've seen the circuit breaker pattern, okay? You see that probably this is something that you should do all the time. Now, let's move to the last thing, one security thing. Let me do a kubectl delete -if Istio files. Virtual service. No, it's not a virtual service, it's a destination rule. Okay, let's go to the destination rule. It's not this one. Come on. Destination rule CV. There we go. And kubectl create -f Istio files destination rule b1 b2. Let me put b1 b2 b3 because now we're going to see a new example, okay, with b1 b2 b3. So basically here you don't know it yet, but notice that here is just a recommendation that is going to be 3 versions. If you do here kget pods, there is only 2 versions, but let me deploy a new service, okay? So here it is, the new service, deployment v3. Oops, okay. Kget pods, okay, it's creating. And the other thing that I'm going to do is send all the traffic to v3. So I can do kubectl apply -f Istio files, virtual service, v3, 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 v3. Here it is. Let me check if. Okay, now we have do curl. Notice that there is a different thing. Notice that it's saying customer preference recommendation v3 and it sends you a date. This date is not coming from my service, but it's coming from an external service. This external service, let me show you here. It comes from this Vault Clock API, okay? So this is a service that there's a REST API service where you send a request and it returns the current time. So every time that I'm doing this, customer it's calling preference, preference is calling recommendation, and recommendation it's calling this wall clock API. Okay, and notice that it works, and you will say, that's pretty cool, right? But this is something that it comes by default, but you should disable. And you should disable because someone could start using your pods to do some kind of data mining or mining bitcoins or whatever, right? So usually what you want to do is avoid that the traffic goes from your cluster to the external wall without any protection. Okay, so to do this, you need to do that. So by default, Istio allows any traffic to go outside, but you can change the config map of Istio, saying that instead of allow any, saying register it only. Okay, so I apply this. Now it's replaced. Usually it takes some seconds, okay, to work. Let's see now. Notice that now it's failing, right? Because it says that, I cannot see it here, but it says an internal server error. Why? Because remember that recommendation tries to reach an external host, and I've configured Istio to forbid external communication for security matters, right? But now probably you're asking yourself, okay, that's fine, but I still want to, communicate to wall clock API. I don't want that anyone tries to communicate with an external wall to any other site, but I want to communicate with the wall clock API. How can I do that? Okay, you can do it in this way. kubectl apply. -f Istio files, service entry egress wall API. Okay, and now I'm going to show you the file. Cut this file, and notice that what I'm seeing here is that when I'm trying to communicate with wallclockapi.com in the port 80 with the protocol HTTP, then allow this traffic. Okay, then allow this communication. Now, what's happening if I do a curl? It works, and the reason is that I've registered this egress rule. If I go here and I remove this egress rule, kubectl delete -f Istio files, service entry, and now I do a curl, it will start failing again. Okay, so notice that you can protect your services, you can protect your cluster using Istio as well. That's all the thing that I wanted to show you. I know that there is some questions, but first of all, there is no more slides. No, just remember, here I am. If you've got any question, I'm going to answer now some questions in the chat, but if it comes, some questions after when you rewatch the session or, in 2 days, you can follow me in Twitter and ask me there in Twitter or in email soto@redhat.com. And remember that all the things that you have seen here and more can be seen in the link that I've shared with you before at the beginning. I'm going to share with you again. Here it is, right? And you will see here how to do simple routing, right? Advancing routing, mirroring traffic, canary deployments, service resiliency, retry timeout, circuit breaker or no circuit breaker, chaos testing, security. In security, you can see this egress example, the example we have seen now, but you can also see the access control list, the mutual TLS, the GWT as well, and airbag. Okay, so this tutorial is full of examples that you can use on your own. So let's see the question. It says, how come V2 is still out of sending traffic as per the graph on a screen? So if I understand correctly, why there is no traffic to V2. The reason is because there is the circuit breaker that has opened the service. So you can see now it's going to be okay. Now V3. Now V3 it's because now it's red because it's failing, because notice that it says here block whole cluster. Okay, so it's blocked, but notice that 5 minutes ago also it goes pass through cluster. Okay, so this is the configuration that we configure. Now V2 is not sending anything because now it's not configured to do that. And before that, when you've got the circuit breaker or the circuit open, then there is no traffic sent it there. Hey Patrick, you say, how can connection coming from your service start mining bitcoins? Well, because maybe there is someone who reached your cluster, get access to the pod, to the container and start doing things. This could be one thing. Another thing is that you've got some kind of developer that, it's modifying the cluster to do this kind of mining. Of course, this is it's a funny example. No? I mean, it's not about mining bitcoins or whatever. It's more about protecting yourself, right? Any attacker could get access to your pod and start making external connections to any site, okay? Or because there is an error on your application, some developer configured, or developer or operational guy, whatever, whoever configured incorrectly any of the URL, and now it's pointing your production cluster is pointing to an external URL which should not be that one, right? So it's more like protecting, right? Not. Is there a rate limiting feature? Yeah, there is a rate limiting feature as well. In version 1.4 and 1.5 there is, but I guess that in 1.6 this has been changed a bit. Okay, I don't know if it's 1.6 or in 1.5. I know that in 1.6 or in 1.5 the rate limiting things changed. But yeah. But you say, should we not restrict ingress instead? Well, but ingress is for incoming, and here what you're controlling is the outgoing traffic. Okay, I mean that. Okay, so basically, what I've got here is a B3 service that it's sending traffic out of my cluster, right? So it's not, and this service is out of your scope. It's external from your cluster. It's in this case Google Clock API. It could be Twitter. It could be Google, whatever. Right, so it's out of your scope. So this is how you could restrict traffic. And I think that's all. I'm very happy I hope you enjoyed the session. I'm very happy that you've been here till the end. And of course, if you've got any question, feel free to reach me in Twitter or email. Thank you very much.